Now we're at session 5. And we have Andrew Zarb, who's a 3D project officer from the Sunshine Coast Council. Andrew is probably one of the most modest users that I've ever experienced in my life in terms of through my interactions with people at, little user group meetings and the like. And I had Andrew actually present as part of my Archicad event in the Hunter Valley in 2016. And the processes that he had in place all of those years ago, from my perspective, I think there was no one actually doing it. And we're talking about councils modelling the whole of their footprint in a software, in a modelling software. And it's just amazing the amount of data that they have. And as architects, we spend so much time trying to, at the start of a project, generating the site, terrain, and the context surrounding it. So Andrew's going to share some of his insights into how we can get information to start off our site at the start of a project. And from my perspective, I think this is, if there's anything that every single person can take away from today, this is the simple session that can save us time in terms of getting all of that information that we need at the start of the project. So take it away, Andrew.
Hi everyone, and welcome to my presentation. We're going to be looking at creating a 3D context model from external data. I'm Andrew Zarb. I'm 3D project officer at Sunshine Coast Council. The Sunshine Coast is in Queensland, Australia. And I've been using Archicad since about 1991. I've worked 20 years with architects and building designers, and for the last 10 years I've been at Sunshine Coast Council. The 3D project was started by a previous urban designer in council, and he used Archicad to demonstrate the possible outcomes of development and of strategic planning. And he found that council had a library of 3D data, so he started converting that from the GIS sources into Archicad, with an aim to produce a 3D model of all the areas where development is expected to occur. In doing that, he found that some of the challenges were that the symbolic nature of the work he was doing wasn't understood by some who wanted more detail in buildings. And as you would understand, putting more detail in a 3D model means more time. And my job was to help with this project to provide more detail. Now, workplaces being dynamic as they are, we ended up from a team of 3 people to myself. And so I had to find some other ways of creating these 3D models that was a little bit more efficient than the methods that are being used. And I had to delve into GIS software. So we use Esri's ArcMap and ArcScene, and now using ArcGIS Pro to extract data that we have and combine it in Archicad with models that sometimes we create and sometimes are provided by proponents of development. And we use these models and we plug them into our 3D model to understand and see what the potential impacts are of development. What we've done in the last few years is we've moved into game engine software, where we have a complete model of the Sunshine Coast. We're still using Archicad as our main method of receiving and preparing models to put into that. We always ask for IFC models, being that that's a standard across all platforms. And what I'm planning on doing today is to have a look at a way of creating a context model from external data. What I'll be doing is demonstrating this mainly based on point cloud, but also from a photogrammetry model. I was hoping to move also more into GIS space and looking at software to use data that's publicly available. But I haven't been able to do that. But I think you'll still enjoy this. And Let's get into the presentation. Okay, this is Cloud Compare. It's freely available software for dealing with point clouds. I'm opening an LAS format point cloud, and you can see that there are a number of scalar fields here. This is just data. It's metadata attached to the point cloud that contains information such as the time that was taken. And this is just a global offset. So on both of these, I'm just going to click yes as it is. This is an offset because the data is geo-referenced. It's very far from the origin. So it just simply moves it so that Cloud Compare can deal with it. Now, what looks like a aerial photograph is in fact a point cloud. It's a 1 kilometre by 1 kilometre tile of the Sunshine Coast. And it's taken by an aircraft with about 4 points per square metre that are shot down, infrared laser. And from each of those, there are multiple returns, which is why we get more than 4 dots per square metre as returns. And that data is then fed into some fairly powerful algorithms, which classify the data for us, which means not that it's top secret. It's split up into different classes. That data has also been run through another process where an aerial photograph has been mapped to the points so that it's colorized with RGB. And that means that we can actually see what the dots are. And what we're going to do for this is we're going to turn on the scalar field called classification, where the different classes are contained. And I'm going to change that color over to a better matching color system. And what we can see here is the different colors represent different type of data. We've got the water, that's blue, the ground is brown, buildings are red. We have 3 types of vegetation, low, medium, and high. You might just be able to make out that there are 3 different shades of green. 2 of them, the low and medium, are particularly similar. And also the medium vegetation only goes up to a height of about 2 meters, I think. So it's not very high. The low vegetation is under a meter. It's really generally just grass and those sort of types of vegetation. On top of those classifications, there are a few more. There's a classification called key points, which is where the algorithm finds points at which the ground changes enough to contain valuable data. Now I've turned on the graph on the right so that we can see what those numbers are. Even though it's a continuous graph, those classes are discrete in whole numbers. And I've just done an extraction of the ground. So that is just the ground as picked up by the LiDAR, and it's going to form the basis of our surface in Archicad. Now, the other thing that we want to do is name that so that we keep track of what our different extracted point clouds are. And the next thing I'm going to extract is the water, because we're going to add that to our surface. So we've got a nice square kilometre tile of the ground and water planes. Now, we don't need to have that much detail in the water. So I'm going to grab the water and I'm going to subsample that, give it a space of about 5 meters, and that'll just calculate the points at about a spacing of 5 meters. It's a bit hard to see on the screen, but those points are there, especially when you increase the dot density. Now, there's a lot of points on the ground as well, and we probably don't need that many for our context site. I've picked this one area to be our context. So what we're going to do is we're going to cut that out, and we're going to keep that at a high resolution, and I'm going to subsample the rest of the point cloud so that it's not so high resolution. That's going to save us a lot of data because you'll be able to see that the amount of points will decrease substantially. So currently, if you look in the bottom left corner, it says points under the heading clouds, 76,500. That's how many points are in that context area. Now, I'm also going to extract the key points. In fact, let's use the key points to make the rest of the ground. They've already been picked out of the ground by the algorithms creating the classes, and that's a much lower resolution than all the ground, so that makes a good ground plane. Let's rename that as well. And what we're going to do now is select our 3 classes that we extracted, manipulated, and we're going to merge them. So it's a merge button there. Let's say no. That would create a new scalar field just to tell us that the 3 came from 3 different sets. We don't need to have more metadata in there. Let's rename that surface. Now, this currently contains the RGB data, which is in here. We don't need that, so we're going to clear that out. And let's turn it on so we can see. So currently all these dots still have an RGB value. We don't want that because Archicad can't deal with the extra data when you're importing the point clouds to create a surface. And the other thing that we don't need is all the different scale of fields. We don't need the classification anymore, nor any of the other fields, which is all data that can be useful to people dealing with point clouds, but it won't be useful for us in Archicad. We now have a raw point cloud, and that's exactly the way Archicad likes it. We can save an XYZ file out of this that Archicad can import, and the extra data would just be unintelligible. If you try and import that, it would just corrupt the import. So we're going to now save that into the right location as an XYZ file. It can be a TXT or an XYZ extension. Archicad's happy with either from memory, but TXT is fine. That's what I always use. Now, what else do we need? It's nice to have a surface, but there's probably a bit more that we can use for our context model that we've got in here. And I think specifically the trees and maybe the buildings could be useful. As you can see, there's some interesting trees around the place, and I think they would add something in Archicad. So we're going to export those as well. All right. So again, using classification as a way of exporting that. We need to switch it to the scalar field when we try and extract it, because the tool that does extraction relies on a numerical value. So if you don't have the right scalar field turned on, those numbers won't mean anything like they do here. Now 5 is our high vegetation. You can see on the right-hand side. We've extracted it. And if we turn RGB back on, you can see we've still got all the RGB values, and we're going to keep them in this case because these ones are actually going to be imported as a point cloud in Archicad, and we'll be able to see those RGB values. Always naming things does help from the confusion. Cloud Compare does like to rename things also when you subsample or cut parts out, as you're about to see. What we're going to do is we're going to cut around our context area, probably just a little bit further out than that, and we'll subsample the area outside of that so that we're not using too many resources for points that are in the distance. Let's grab that, subsample. Let's see, what do we reckon? Maybe 1 meter is probably enough to get the vegetation at a distance. And now we can turn on the original, which we haven't subsampled, and we can stick those two together, merge. No, we don't want to generate that. And we'll rename this file. Okay, let's delete the scale of fields for this because, again, Archicad's not going to use any of those. Delete all. Okay, we've got rid of that means it gets rid of the classification and all the other metadata that's contained in there. Archicad can't use that yet. No, I don't see the point, but we'll now save it as an E57 file, which is the point cloud file that Archicad likes to read. Fortunately, Cloud Compare can deal with all these different file types. Right, let's extract the buildings. The buildings are class 6. And the other thing we're going to extract from here are the key points. They're number 8. Okay, there's the key points. Now, the aerial imaging doesn't take vertical surfaces in very well because of the altitude of the plane. And when we create a surface in Archicad, it would just create a big blanket over all the point clouds and just span between the points it finds. One of the problems we can have is that it'll create lines that find the nearest point. It'll be sort of diagonal in a elevational view. So we've moved the key points down in elevation so that when Archicad creates a surface, it creates these vertical lines, or as close to vertical as we can. We could move it down even further so that it finds, in plain view, it finds the nearest point and generates a shape going down to that nearest point. And by doing this, we're going to get the tops of the building something like an extrusion, essentially, out of that ground. We're going to import that, and you'll see what it looks like. Now, this is Archicad. You might recognize it. Don't laugh. That's the way I use it. The first thing we're going to do is place a mesh from surveyor's data and import our surface. And what we do is zoom to the new data that it imports. Now, don't get scared when you see my coordinates in the bottom left. Trust me, I've done this. It works. Because I haven't got anything near the origin, Archicad seems to handle it just fine. I'm working 7,000 kilometers away from the origin. I don't always do this, but this is how it imports. And it seems to work just fine for me. I'm sure I'm going to get a lot of people asking me how on earth that works or telling me why that's a bad idea. I've been doing it for 10 years. I haven't blown anything up yet. Right. Now let's change the material of our mesh to something that we can use for our buildings when we import them. And once again, we're going to import a mesh from surveyor's data. We don't need to zoom this time, we're there. That's going to import that. Let's have a look at what that looks like. Now, all of this is geo-referenced, which is why it comes in at this point. This is based on our mapping system and the datum points we have. And it's very important to have a datum point if you want things to line up. Fortunately for me, everything of ours is geo-referenced. I'm going to put a slab there. We're going to use that slab, and we're going to use a 3D element operation to cut the base of those buildings at ground level, just so that we get rid of that rubbish down below ground. I didn't have to make that any thicker, but I just like the way that, just like the idea of it. So we're going to do solid element operation. And that's our target. And we're going to select our operator, and we're going to use subtraction with a downwards extrusion. So it's going to cut it at the ground and delete everything below. Let's have a look at that in 3D. It's probably going to be easier to understand what we're doing. All right, so there's our slab, and all we're doing is the white buildings are going to be cut from that slab down. Hit execute. Through the magic of television, this won't take as long as it does in real life. Some of these operations can take a little while. Now, I find that solid element operations can tend to slow things down as well, especially when they're on very complex elements. So once we've done that, what we're also going to do is convert that to a morph, and that way it doesn't rely on the solid element operation anymore. It becomes independent, and we can delete that slab because it's no longer relying on it. I'll just take a moment to do that. And our model will be starting to come together. It's very complex. It's going to take a while, as it does. That's something that I'm used to seeing that most people might not have seen. For those who are wondering, this is running on a Intel i7. I should have looked up the specs. And about 3.5 gigahertz and NVIDIA RTX 3090 graphics card. Now let's import those E57 point clouds. And I'm going to import the vegetation. Now, I like to put the libraries with my project. I'm not sure about you. I don't have a need for a library of just point clouds. So I'm going to create a folder in here where I have all my data. If I can rename that. I could blame my ligament in my left hand for my bad typing skills, but that probably would be unfair considering the P's on the right-hand side. All right, let's import these trees and let's have a look at what they look like. Now we're going to let Archicad place them at the origin because, again, they're geo-referenced and they're going to come in the right spot for me. And like I said, you want a datum point that you can rely on. It's very important if you want things to line up. There's our trees. All right, I think they're starting to look like something. Okay, now when we go to plan, you notice that we can't see the trees. And for those who haven't imported point clouds before, the reason is that they come in as a library part, and you have to override the floor plan display range, which is from 0 to 1.1 meters, so you can see them. Let's just put in something like 100. That'll put all of them in, and they're there. So they pop up in plan. We can see them in plan. Now you can actually pick that object from any of the points. This is missing an aerial image, isn't it? So here we are in Photoshop. Now we've got a beautiful aerial image, which is also the same square kilometre tile. The problem we have is that this is very high resolution. So 1 pixel on this image equals 10 centimetres, which is fine if you're looking for that detail, but it's just going to be too much as a texture in Archicad and really not necessary. Of course, if you're doing a context model, you might split into two. You might have a high-res section around your subject site and then a low-res one elsewhere. Let's just make this 1 pixel per meter. So because it's 1 square kilometre, that'll be 1,000 by 1,000. That's a very reasonable image. And what we're going to do is just save that into our directory. Let's just make it a JPEG while we're at it. Just reduce the file size. Okay, that's done. Let's go and have a look at it in Archicad. We're going to have to place this. Now, we are fortunate in that it's going to tile in the right spot, even when it's that far from the origin, because we are located in an increment of 1 kilometre from the origin. Let's make a new surface. It's going to be called King's Beach because that's where it is. Now let's select our mesh. And let's apply that surface to the mesh. Find King's Beach. There it is. There we are. We have a nice surface which we made from a point cloud with a texture of the aerial photograph mapped to it. Let's turn everything else on. There we are. We've got trees, we've got buildings. It's looking pretty good. Let's have a look around. Okay, now there are some limitations to the quality, as you can see in the buildings particularly, and there is another way that we can import things into the context model, and that's if we find other 3D data. Now, fortunately for me, as well as the aerial laser survey of the whole Sunshine Coast, we've also got a photogrammetry model of let's say the larger portion of the developed area of it. This is a surface model, so it's not solid. And it's generated from a helicopter flight taking thousands of photos, which are then brought into software, which generates the model from the photographs. This is also done to a particular precision so that we know that we can rely on it. And I've got a high-res portion of it on the subject site. And what I'm going to do is delete part of the low-res model to essentially meld the two together, just to show that you can edit these. So we are in Blender, by the way, if I haven't mentioned it. What I'm going to do is use the knife tool, and I'm going to cut that mesh. And what that does is it's going to cut all those triangles where I put that cut line so that when I delete the vertices, I don't end up with polygons missing outside of that section that I cut. It's essentially like a boundary where I've sliced it, because otherwise what you find is that you might get holes where the two join. If you have a triangle that, goes past the boundary, I'm not going to get too precious about joining them perfectly. They are slightly different because the two captures have been done at different times. So not having, perfectly cut lines probably actually going to help them join. So we're doing the same to that other tile. As you can see, this is made up of a few tiles. On the top right-hand side, you can see all the separate tiles that I've brought in. Turn them all on. We've now got a model of our context area, and we're going to save it so that we can open it in Archicad. Archicad can import a collada file. So we're going to export this as a collada file. I don't think there's any other settings we need to change. It's all correct. Some software will have the y-axis as the up axis instead of the z, and so you'll find that models rotate 90 degrees because of that. That's just what I was checking then. Right, it's saved. Let's go back to Archicad with a new file, and we're going to open the collada file. This is going to make a new project where it imports that as a object, and it'll place it for us. So here's our collada file inside of Archicad. So the limitation is that as an object, we can't really do much to it. Right, so let's move it to where it needs to be. Let's save this so that we don't have to do it again in case something happens. Of course, you can always rely on Archicad's autosave, but it's best to save often and not get out of the habit, because other software can't be trusted the way Archicad can for you to autosave your work. All right, just got to wait for that merge to finish. Okay, so here we have a complete model. So we can see the buildings we imported before overlapping the photogrammetry model. So everything's on at the same time. Let's turn those white buildings off now. We could turn the ground mesh off as well, but there we are. Now, I said I was going to show you what to do about textures that don't line up. So here we've got a little cropped area and a little cropped image. Now, I do know exactly where to locate that. So I know my image is in the right spot in relation to that model. And I've just drawn a slab there at the corner of the image. And made a surface of that image that we're going to apply to the mesh. And when we do, we can see that it's not in the right location. Okay, and the reason for that is the origin doesn't line up with the tiling of the texture. You don't have to worry about why, but that's what it is. So I set the origin to that corner where we had that image, and there you go, magically. That pops up. Do you understand what I did is I set the origin on the bottom left of the image, put a slab there, and that corner coincides with the origin of the image. So when I clicked on it, it all lined up. Now what we're looking at here is Council's model. This is all the photogrammetry. There's various levels of detail here. This is inside Unreal Engine. Okay, so inside the gaming engine software, we can bring a huge amount of data, and we've got a combination of the photogrammetry model, some point clouds, and here you'll see a model of a building. It's a very simple model, which was created in Archicad. And the purpose of that was just to understand what the building looks like in place. I'm just flying very roughly through this, but there's the very simple building that I've put in there. That's roughly the dimensions of a building which someone's proposing, and we can sort of look at that and understand what that's going to look like in place. And together with the planners, we can make decisions about what we think of that. We can understand the impacts, the visibility of it, and all that. That's essentially the reason for this Sunshine Coast 3D model. And here's an urban area. We're in Maroochydore. And so this is an extensive area of high-resolution tiles put together of the majority of Maroochydore going down the main street. The beauty of this is there's no traffic. So the only cars that are captured were the ones that were still. When the photo capture was done, all the moving vehicles and people have been deleted. So just a bit of a flyover just to show you how much of the model there is around Maroochydore. And so this is what we're using for a lot of our work. Okay, I think it's time to wrap this up. Thank you very much for your time. I hope you got something out of it. I've enjoyed showing you this. Unfortunately, as I said, I didn't quite get a chance to show everything I wanted to. So we went through using Cloud Compare and Blender for converting models into Archicad. What I didn't get a chance to do was to use QGIS software and import open data sets that are available freely from various sites. And what I wanted to do with that was to import some cadastral boundaries, contours, and digital elevation models, and converting that 2D and 3D information for use in Archicad. Time just gets away, and it sounds like it's something that I can do in another video. What I'll do is I'll put the links up for you to have a look at, and for those who are curious, you can have a go at converting that data yourself. Okay, well, I wish you all the best in your endeavours in the 3D world with Archicad, and I hope to talk to you soon. Thank you.